Привет, пожалуйста. Hi and welcome to the Pole Shift News, guys. You might be wondering why sometimes I'm speaking Russian or introducing the beginning of these videos in Russian. It's because my partner is from Lithuania and I'm trying to learn the language, or as best I can at least. We are planning to go over to Lithuania, and you know, there was something we talked about just briefly, if we could travel from Lithuania on a sleeping carriage to Russia on around about the 9th of May this year, if we're lucky enough to, you know, get the money together to do this, because you know, on around about the 9th of May, I'm not exactly sure of the date. You know, they have their arms parade. I think it's something to celebrate Leonard. I'm not 100% sure, so forgive me. But I'll tell you what else as well, guys. It'd be nice to encourage some more subscribers from that region, and with a bit of hope that we could probably get one of our magnetosphere sensors in that region, because you know, the magnetic North Pole is migrating over towards Siberia. So if we could get some more subscribers, you know, we could put one of our magnetosphere strength sensors there, because I suspect as the pole migrates towards Siberia, then it's going to get stronger, the magnetosphere in that region. And you know, well, just having the magnetosphere in that region would be, you know, one of those things, whether it is going to be the case, more magnetosphere strength as the pole gets over there, or less, you know, in general, you know, just having it there would be what we needed. As we can see, guys, we'll just get rid of that. We've got a quiet geomagnetic field and normal solar X-rays. And it's not surprised, because I mean, when you look at the disk, there isn't any visible sun spots there, as has been the case for a while now. There's a little bit of magnetic activity equatorial on the disk, as you can see, but that again is not uncommon, because as the solar cycle comes towards the end, we start to see equatorial sunspots, and towards the you know, the middle of the solar cycle, we expect to see around 30 degrees north and south plenty of activity with sunspots. Will that be the case for solar cycle 25? We just don't know. We're in a bit of a quiet period now, and you know, despite the fact that a lot of scientists have already predicted that you know, we could have already seen you know, the grand solar minimum start, and therefore not receive any solar not even see a start to solar cycle 25. So you know, but if we look at where we are, you know, it's all stands to reason. We're at the end of solar cycle 24. It's been a short solar cycle. Some of you guys have asked many times, why do we have solar cycles, and you know, what has caused this solar cycle to be a short solar cycle. I don't know, guys. It's the honest answer. You know, it's not the same as the Earth. The Earth takes a lot longer for its magnetic poles to reverse. The Sun seems to go through them on average, in normal times, well, not in normal times, but on average every 11 years. And what is causing this weakness in this period of time could be, if I have an educated guess, could be to do with iron clouds in the stellar background, which means our Earth, or our solar system, has moved into an iron cloud. The reason why I say iron cloud, there will be other elements in that cloud, but if we just look at the composition of our planet, we know that we've got a large iron centre. We've come to that conclusion on, you know, sending shock waves through the crust and receiving them at different points of the Earth. We also know that when there's an earthquake, these waves, such as Rayleigh waves, S waves, P waves, travel through different materials at different speeds. So that's how we know, or we've got an idea to the composition of what's inside our Earth. So you know, I say an iron cloud that our solar system's moved through, because there is plenty of iron in the stellar background, and I suspect these spiral arms where interstellar gases are in abundance, we could be passing through one of them clouds right now. And if you remember, NASA themselves were talking about such a cloud that we was entering. Now, if we're moving into an iron cloud, then, I would suspect that that could have an effect on our sun, and in turn, maybe affect our planet. But, the sun goes through a magnetic reversal every 11 years, and the planet is a little bit slower in its process. And I'm not sure, or I haven't seen any convincing evidence to say that the two are linked in any way, because if that was the case, surely we would have more magnetic reversals than what we get. The other thing is, this Earth at the moment is overdue a magnetic reversal, and has been for 500,000 years. So, what we do know is what we've got at hand, and it looks like we're going into another grand solar minimum. This has been on the cards now for 7 years. Some mainstream scientists have predicted it for all that period of time, and from what we're seeing, it looks like that is going to be the case. Will it lead to another ice age? Like I already said, guys, we've been in an ice age ever since the last ice age began. We are still officially in an ice age, but will it lead to a glacial period? I think so. And, especially when we look at a lot further record in time, we can see that sunspots for at least the last 11,000 years have been dropping off in the same manner. The other thing I wanted to talk about, guys, is what's going on in the UK with regards to crop production and farming. And I'm pretty sure if there's any farmers that subscribe to this channel will understand what I'm saying with regards to the forcing of crops. We're having to add, and this is something that I overheard even a couple of farmers in this region, because we live in a little village here, and if you put on a ham radio, you can pick up some of the chatter between them on the evenings. And I heard these two farmers talking about the forcing of crops, and it's going to come to a point where they're going to struggle to grow stuff on these fields, because the demand for production has led to them having to force the ground by adding nitrates to it or whatever, depending on whatever crop they're planning on growing. They have to add these nutrients to the ground in order to grow the crops, because the ground has been saturated with certain crops over the years. It's stripped out these particular nutrients that make them thrive, so they're adding to it. So my point here is, guys, if we go into difficult times, which it certainly looks like we're going to, climate's going to affect crop growing. Seasonal changes is going to affect crop growing. It's going to reduce these things. It's going to make it very hard for farmers to even at some point to afford to force the lands in order to grow the crops. If we end up with a grid down situation, they're just not going to get those crops, because the chemical industries will be shutting down as a result of a grid down scenario. So can you see how even if you have the intention to grow your own food, you've got your own crops, seeds, the land isn't going to be able to support great sustainability of large populations. It's just something that is always getting targeted, the large populations. In all these scenarios, you end up with another glacial period. You're going to end up with mass migration to the regions on this earth which are going to be able to support crops. If you add later on down the line, pretty much minimal magnetosphere, then we're going to end up with a lot more health problems as a result of cosmic rays. Not only wetter climates as a result, even in these equatorial regions you're going to see floods where you've never seen them before, and monsoon seasons are going to be extended, and also we could see droughts in these regions where you would expect during a glacial period to be very fertile lands. We're going to see the opposite. So there's a lot of things that are going to change the way we do business. So In all these scenarios, like I say, the end result is pretty much the same. 7 billion souls on the planet of Earth, and there is a demand for food to feed them. The way things are going is terrible. There is mismanagement and bad stewardship across all the ranges. We're not looking after the species. We're not looking after the lungs of our planet, which are the rainforests. What's happening over there is a crime. Sometimes, when I have these logical thoughts, I think to myself, what are we doing? We're actually killing the lungs of the planet by deforestation. And what are we doing? We're levelling these rainforests to produce open spaces for, pasture land for, cattle. It's insane when you think about it. We are a species that claims to be intelligent, yet at the same time kill our own lungs. These rainforests are a rich diversity of species, and not only that, they are the lungs of the planet because, a lot of the oxygen is coming from vegetation such as that in the rainforests. I'm looking at these Arctic sea ice extents, and, in the back of my mind I'm thinking about what was said about global warming, at least from the 80s. But when you look at the average line from 1972 to 2017, you can see that there is more kilometres of sea ice over the Arctic regions than there ever has been on the average line. Yes, you can see the red line represents 2018, and this is updated every other day or every day on the website Pole Shift News, and you can follow it. It does tend to be at the bottom of all these lines, but what do you expect, guys? When if I just show you back on the solar data part of this website, you can see that at least from 1950s to 2000 or the present date that we have experienced a lot more sunspots. And we know, even a child would say that, if there's more sunspots now, hopefully, or, if there's a warmer sun, then there's going to be a warmer planet as a result of it. But what I'm saying is it's common knowledge now, and, it's no coincidence that when we get more sunspots, we have better climates. But with regards to those ice caps, well, if you're going to have more solar activity, which is going to deliver more solar radiation on the planet, it's going to warm it up. And those caps are going to shrink in size. And over a period of time, you're going to lose some of that ice. So, if I say from 2007 to the present day, there has been a slight increase, and those caps are regaining, their territory, what they had before, it's going to take some time. These are very slow inertias, so they will come back, especially when we have periods such as the grand solar minimum coming back into play. They will come back to what there was before, and even extend, especially if we're going back into a glacial period. You'll see, that over the coming years, you're not going to see it straight away, that's the point. Over the coming years you will, but because it's a slow inertia, it's a grand system, those ice continents over the northern and southern hemisphere, and is another thing as well, you guys, when you think about a migrating pole taking those ice or those Arctic regions along with the pole, then they're not going to be in the same regions as what they was 20-30 years ago. They're going to be moving towards Siberia. If you pinpoint the dipole over the Arctic region and allow for a little bit of time for the inertia to catch up, then what you're going to see or witness, and we will do this in the next 15 years, witness that territory of ice migrating with the pole as it does so. So, when I see in science we always put our average line over the charts to get a better idea of what is actually going on. And when you look at the average line, that broken line, which represents 1972 to 2017, you can see that there is more millions of kilometres of ice than there ever has been from that point. When we look at recent times, obviously it looks less. But if you look at the grand picture, you can see that there is more sea ice over these regions. And, again, these are updated regularly. Okay, this is a couple of days old, but, that's nothing when you're talking about, this topic, the sea ice concentration and the sea ice extent over the northern and southern regions of this planet. So just before we finish, guys, the theory I had a few years ago, and I still think it's holding, that being, when these poles, both over the northern and southern hemisphere, migrate, they take along with it those Arctic cold regions. As a result, I think we'll be seeing, as they migrate in those regions, and I think we can see, at least for the Antarctic region, it's not so clear, and I'll explain why over the northern hemisphere, but at least for the southern hemisphere of this planet, we will see a clear movement of ice in the direction of the pole when we look at the average line of ice where it normally is. We'll do that, but just to give you an idea, so you can see where it's migrated off Antarctica, and you can see that it's heading, when we look over the Arctic Circle, it is heading towards Siberia. So we would expect to see then on the content maps of the ice, you can check on the website if you like, we should be seeing a movement of that Arctic climate and ice forming in the direction where the poles are moving. So if we look on the sea ice content charts at the yellow regions, which is the average line or meridian, we can see for the south magnetic pole region, or the Arctic region, that there is some movement of ice over that region, and we can see over the other side where the pole's leaving the continent a bigger gap. So I think there is early supporting evidence to back up that theory with the fact that we can see ice moving over the boundary of where the pole is migrating and taking that Arctic climate with it. But it's a little bit difficult over the northern hemisphere, and that is because where it is land, they don't put the yellow line. But having said that, we can see that the yellow line on this side does have more ice over that region. It looks to me to be southern Siberia, and like I say, it's a little bit difficult because they don't mark it on the land like they do around the ocean. That's because it's measuring the sea ice concentration and not land concentration. But if they did measure the land concentration, I would dare say we would see more movement over that line like we do over in the Antarctic region. So guys, I think the theory is standing good with the both migrating pole and the ice moving in that direction. If this is true, there is one other anomaly that hasn't moved yet. And we've checked this on this channel. Remember, we've went outside, and on the solstice we've measured how the sun rises. And the reason why we've done that is because we are checking not just to see the rotational axis is still where it should be, but for other things as well, other wobbles and such during these times. So, we're covering as much as what we possibly can with regards to those three anomalies over the northern and southern hemispheres. That being, rotational axis is over in that region, the magnetic poles are in that region, and the Arctic circles in that region. If we see one move and then the other move, the ice and the Arctic region with regards to the climate moving with the poles, then how long will it be before we see a rotational axis? It could be the last in the line of anomalies to move, but I would say that these aren't all in the same region by coincidence. So if we see one move, we could see the other move. I think we've got time just to fit one more thing in. So I think it's worth talking and mentioning the South Atlantic anomaly, and that's this region here, the blue region. It's a concentration of weak magnetic field measured on the Earth surface, and it's never called, for some reason, the South Atlantic magnetic anomaly, but it is always called the South Atlantic anomaly. It's assumed that people know what it is that's been spoken about. So just in case you ever come across that strange phenomena, you know now why it is. So, why is it worth mentioning? Well, it's the weakest part of the magnetic field over the Earth, and has been at least for 80 years. Even in the 50s, you know, some experiments was, as I've mentioned before, conducted in this region specifically involving nuclear missile tests detonated in the atmosphere to see what would happen. You can look up, I forget the name of the project at the time, it just is not with me at the moment, but you know, if you look it up on the internet, you'll see what there was actually testing, what were the results of those tests. But for us, we're more concerned of what happens with regards to sputtering. And, you know, when a planet loses its magnetosphere, sputtering takes place, it's stripping away of the atmosphere. And, you know, what will be the result of that happening in this region on this Earth, and, you know, will it have an effect of the gases in the atmosphere? And the only way to know for sure is to do the tests. And for that reason, we did measure the oxygen concentration of the atmosphere a while back on this channel. So I think, you know, over the next couple of days we'll get the experiment set back up, and, you know, we'll measure the oxygen content now just to see if it is at the levels it should be. If not, maybe it is as a result of this area and the further magnetosphere weakening over the last 10 years could be resulting oxygen being stripped away from our atmosphere. And the reason why we're going to check the levels of oxygen in our atmosphere is because it's important to us just as much as the food is on the planet and the production of food. You know, we've got 7 billion souls, and they all require oxygen, as well as all the other air-breathing diversity of species on this planet. It's very important for us. And, you know, there has never been so many oxygen-breathing life forms on this planet. You know, we are one of the massive increases of consumption of oxygen. Not only that, when we think about how many cars we've got on our planet, consuming oxygen as part of that combustion in the engine, you know, there's another reason for us to just examine and keep tabs on how much oxygen is being used in the atmosphere and how much is in the atmosphere. Now, we know there's a lot of CO2 in the atmosphere. That's good for all the vegetation. That gives us, in replacement for that CO2, oxygen back, such as trees. So that's good. But like I say, it's funny because I was talking to my son while we was waiting for my partner the other day about, you know, how much oxygen is consumed in cars. So you imagine 1,000 revolutions per minute the engine cycles. Usually, in Europe, we've got cars with 4 cylinders, and I would say at least 1.5, on average. Most cars have a 1.5 litre engine. That's the amount of capacity in the pistons when they fire. I'm sure a lot of you know about this already, but, you know, for every combustion, of one pot or one piston chamber, there has to be a certain amount of air mixed with the hydrocarbon, whether it's petrol or diesel. So you imagine if the engine's cycling, you know, on tick over without you accelerating it at all 1,000 times. Just imagine how much oxygen is being consumed in that engine running. And then, you know, you just imagine how much, you know, other things that consume oxygen in the combustion process, such as aircraft and then ships. You know, not all of them are nuclear powered. In fact, the majority of them do burn, a hydrocarbon fuel, whether it's crude, heavy oil, diesel, petrol, you know, all these things, or jet fuel, whatever brand it is that these airlines run on today, will all need oxygen in the process of combustion in order to turn it into some form of kinetic movement. So, you know, not only us, and the 7 billion of us are consuming, a lot of oxygen. You know, all these things that we have around us today are consuming a lot of oxygen, as well as the cattle that we now intensively rear are all producing a lot of oxygen, and I would like to know the levels of oxygen in the atmosphere compared to times back since the Industrial Revolution. How much of shift in balance has been the outcome. So yeah, that's why we're talking about this region, because it strips the atmosphere. We know there's a lot of oxygen in the atmosphere. It is like water. These heavier elements in the atmosphere are going to be lower to the ground because of the gravity is going to layer them. Like if you put water in a glass and then you add oil to it, it's going to float on top of the water. And then if you add lesser dense liquids on top of that, you're going to end up with perfect layering, like you do see sometimes in sedimentary rocks. But it's an interest to this topic because all these things are changing. We don't talk about them enough. They're certainly not going to mention this stuff on the news because, how many people would just switch off the news if they started talking about the layers in the atmosphere of gases and, as a result of this, how much has been consumed back since the or at least since the Industrial Revolution. People would soon switch off in this modern age because they'd rather watch, other things like their favourite soap series or the Gogglebox, people watching TV and being filmed watching TV. It's insane. But you would think if we shrunk our environments down to little bubbles, which in some cases we do, but for other reasons, let's say we was on a spaceship, all these things would be more critical than ever because any one of them could lead to us being, dead as a result of not having it. But it's all took for granted on a scale the size of a planet. This is what I try and sometimes bring over to you guys. Don't be just taking all this for granted. It is a special gift to have a biosphere, be positioned where we are on our orbit around the sun. All these things we take for granted, but we do live in a hostile environment, even though we live on a big planet which has got a protective magnetosphere, which has got gravity which allows the oxygen to be in the region it is so that we can breathe it. We do take it for granted, and it is a hostile environment, like I say, because we're moving. And I got this wrong. I said we was moving at 24,000 miles an hour. It's actually 1,000 miles an hour that the Earth rotates. It's 24,000 miles in diameter. I get those two sometimes when I'm talking about a lot of things confused, or the other way around. But we're moving not only 1,000 miles an hour in rotation, we're actually moving around the sun at around 62 to 72,000 miles an hour. You just couldn't put your hand out of an airplane window if it was able to move that fast, because it would soon turn to dust. It would vaporize because of the heat of the friction. But we're protected by our magnetosphere. We're protected from our by our atmosphere from all these things, from the cosmic rays and from the whole thing burning up from the magnetosphere. But there's something else, guys. And we can see this. It's evident every day we look at it. The moon, we can see, we narrowly avoid every day being struck by meteorites. Remember the one that passed over Russia a few years ago? As it did, the sonic booms blew out windows. These things are not uncommon to happen. We're just lucky that they don't. The small ones vaporize. For the same reason, they come into an atmosphere which is rotating at 1,000 miles an hour, but they come in at such speeds that they just burn up instantly. But nevertheless, thousands and thousands of tons of iron are added to the mass of this planet every single year. It's just that we just see these little things burn up. We just don't, take our time out to equate for how much of it is actually coming in. But these things, if everyone tonight went out, for instance, on a clear night, would see at least one or two shooting stars. When we pass through these belts of shooting stars, you see meteorite showers. And just imagine all these grams and half-pound meteorites that do make it down to the surface. And the difference between making it down to the surface and just skimming off our atmosphere is the fact that it's called a meteorite, that it's hit the ground, and not a meteor as it's skimmed off, do mount up to tons and tons every year. But if you look at the moon, guys, you can see it's potted all over with meteorite impacts. You know, if you look at a satellite image from space back at Earth, you won't see it, or you won't see at least the ones where there's vegetation growing, because they soon cover up these scars on Earth. But out in the deserts, you'll see, you know, and rocky terrain regions, you'll see that these things are, you know, not uncommon to hit Earth as well. And we're very lucky that, you know, more of them don't. But we do, like I say, live in a hostile environment. This is like a giant spaceship for us. It takes care of a lot of our needs for us, and we take it for granted. You know, I think if we was a more intelligent species, we wouldn't just leave it all down for nature to do all this for us. I mean, we are like children on this planet in that respect, that we, you know, we just take it all for granted. I mean, why haven't we invested time, knowledge and money into producing our own magnetosphere? You know, just think of what we could do with that. We could probably recolonize Mars and even our moon if we could come up with an artificial magnetosphere. The magnetosphere, with regards to planet having survivability for its species on board, is all down to having a magnetosphere. You get rid of the magnetosphere and, you know, you will end all the biodiversities alive on that planet. So, you know I have gone on a little bit longer on this video. I know some of you appreciate, you know, me talking about these subjects and not just reading from a script and getting the points out. I know some of you prefer that, some of you don't, but, you know, in general, try to talk about a little bit more than just a few things on this channel, and give you I think you get my feedback from doing that. So, you know, I'm going to end the video here, guys. I'm going to say big thanks to those few people recently that have supported the channel, more supported the channel than we ever have. For some reason, I think it was because I mentioned, you know, the fact that, you know, we live in a modern day society where things are paid over the internet by credit cards, and in order to make a contribution, you've got to do that. And I think I also mentioned, you know, some of the efforts I put myself through to inform you guys as well. I think that's sunk into some of you guys out there, and that's why we got a few people to support the channel. But you're not just supporting somebody talking about these subjects. You know, we've got our own observatory here, and, you know, we do measure the magnetic North Pole. We do measure the magnetosphere now, and we do occasionally check in on for ourselves, so that we know that we're not just being told it by organisations, such things as oxygen content in our atmosphere. And we'll do that over the next week or so. We'll have one where we set up the experiment. You'll see how we do it if you've not seen how we measure the oxygen content on this in our atmosphere. If you've never seen it before, it's very simple, but that's the way we do things on here. But it's very accurate, just as is a gas analyzer would be. But, you know, we just don't have the funds to buy a gas analyzer. It would be nice, wouldn't it? Wouldn't it be nice, just like we're building this the cloud chamber, to not have to go and buy the dried ice in order for us to get a visual? We can just flick a switch. You know, if we had a gas analyzer, we could just flick a switch again, but, you know, those things are mega expensive. So we find other ways, you know, to do it on this channel, but nevertheless, you know, it's just as accurate as having a gas analyzer. You know, we can get a good idea how much oxygen's in our atmosphere with the methods we use, and you'll see how we do that anyhow over the coming days on this channel. So, yeah, thanks again, guys, for supporting it, and if I can encourage a few of you other guys out there to support it, you know, please do so. We don't know where we can take this. We've just peaked, I noticed the other day, over 13,000 subscribers to the channel. And, you know, we added, I couldn't believe it, over 30 subscribers since just yesterday. So, you know, we're getting more attention now. Hopefully we'll continue doing that. We're not going to fall into the same mistakes we made the last time by trying to monetize the channel on YouTube, because that just leads to restrictions as far as observable content in different countries. Some is accepted, some isn't, and if you've got a paid channel, you can't do it. The other thing is, I don't want you to come onto these videos and be bombarded with adverts that you have to wait in some cases 30 seconds to end in order just to get on with the content of the video. And for the same reason, I'm not going to take any corporate sponsorship because I don't want them dictating to me as to regards to what sort of things I can put out on my website and on my channel on YouTube. That's why we don't advertise like that. The other thing is, some of you mentioned, I'm sorry for the going on in this, but some of you other guys mentioned, why don't you come up with Patreon? Well, some of you mentioned, and quite rightly so, we would rather give you all the money as opposed to giving you some money to support the channel and you giving us something back. And that's usually the way things work on Patreon. You have to do a bit of merchandising. I don't want to even waste my time on all your time. I'm sure you don't want a t-shirt with maverickstar printed on it, or a cup with maverickstar printed on it. If you're going to make a contribution to the support of this channel and research observatory and website, you're not interested in having a keyring from me. I know that you're interested in making the support. You don't want me to use some of that money on keyrings, t-shirts and cups, which you've already got enough of in any case, guys. So I don't want to waste my time or your time in doing that. It's not that I don't want to give you nothing back, because I hope that in the data all that we collect now from the observatory and the information that I give you is enough in return for your support. So that's why we don't do these things. I think it's worth telling a few of you guys that's why we just don't do it. It's just, I don't want to get into it anyhow. I don't want to waste my time buying t-shirts and cups and mugs, and then waste further my time sending cups all over the world, having to find out international costs of sending the parcels here, there and everywhere. I did mention this to someone recently. I do think I've got enough information, and it's not going to be just magnetic pole related and what current events are related. Possibly enough information to create a book, but it's going to be more along the lines of the universal equation. It's going to be talking about the flare of life patterns, geometry, maths and things like that. That's what I was thinking about adding, and about Egypt, the location of these megaliths that are here on our planet, and what our ancestors thought of these things. That's what probably the content of that book. I do think I have got enough information to probably put it down in a book and make it interesting enough. And the way I would probably present that book would be on Amazon. You could probably buy an electronic copy, and that would save sending hardback copies here, there and everywhere. I would send some out, but that's probably the limit, and it's not something that I've started to do. I've not started to write that book, but it would probably be the limit that I would go to, and I think that would be enough for you guys, because I know a lot of you guys are interested in those topics that I've mentioned before. So I have gone on well more than what I should have done. I will end the video here, guys. I'll say this: I hope you enjoyed your Easter holidays. There is a link there if you want to support the channel, and guys, tune back in over the next few days and we will do that experiment where we measure the content of the oxygen and talk more about the processes of the magnetic reversal, because it is the most important anomaly taking place in our lives right now. So enjoy the rest of your week, guys, and I'll say bye for now.